Hi, welcome to D2KSS. In this current session, we are going to discuss about Azure Event Hubs. So the Azure Event Hub is a fully managed real-time data injection service that's simple, trusted, and scalable. The Azure Event Hub will help to process the millions of events per second from any source to build a dynamic data pipelines and immediately respond to the business challenges. So the Event Hub is a fully managed, meaning that it is a PaaS service which helps to process the real-time data. So the Event Hub will take the data from the producers or providers and will transform the data or transfer the data to the consumers who subscribe that particular topics. The data sent to an Event Hub can be transferred and stored by using a real-time analytic providers or batchings or storage adapters. So now we talk about Event Hubs overview. So Event Hub represents as a front door for event pipelines, often called as the event ingester in the solution architectures. An event ingester is a component or a service that sits between the event publishers and event consumers to decouple the producers who is generating the events and the consumption who consuming those events. So I will tell in a layman terms that the box which we are showing here is a gated community. In that gated community, there is a houses has been built. In that each house there is some sensor devices has been installed, like a smoke detectors or something they have been installed for each house. These sensor devices has been connected to this event hub. So this whatever the data collected by these sensor devices will transfer the data to the event hub in a partitions. We'll talk about what is the partitions in a while. So it will, the data which is collecting from these sensors, it will transfer to the event. So these receivers who is monitoring this data, they will subscribe these particular topics or this particular data. So this whoever subscribes this data, the event hub will transfer the data to them. So one thing we have to observe here is the event hub sits between the producers and the receivers. And one more important thing is there is no dependency between producers and their receivers. Even they don't know who is consuming, or they don't know, receivers don't know who is producing the data. So Event Hub provides a unified streaming platform with time retention buffer. So based on the tier you have selected, the Event Hub will provide the retention policy. For example, there is a 3 tiers is there in this Event Hub: basic, standard, premium. If you choose basic, the data retention is 1 day, maximum is 1 day. If you choose to create this Event Hub is standard, then 7 days. If you choose premium, it is 9 days. So we'll talk in a while the price tier features in a while. So why we need the Event Hubs? As we discussed that Event Hub is a PaaS service. So for all the PaaS service, you no need to focus on the infrastructure. Azure will take care to provide a up-to-date infrastructures, servers to create the Event Hubs. So developer can focus drawing or creating a maps how to get the data from the producers, build a real-time big data pipelines, and respond to the business challenges right away. So developer no need to focus on the infrastructure configuration, etc. They can focus on their business challenges. So the characteristics of the Event Hub is The configuration of Event Hub or data pipelines configuration is just simple with a couple of clicks. Seamlessly integrate with your Azure data services to uncover the insights faster. And the data which we are processing through Event Hubs, it is protected, and Event Hubs is certified by CSA star, ISO, and etc. There is many certifieds is there. Scalable, and you can able to scale dynamically as per your usage, and open. So you can able to connect to Event Hubs through AMQP, HTTPS, or Apache Kafka. So you can integrate with the Event Hub with any source using these protocols. So now we'll talk about Event Hub use cases. Normally, some of the banks will use Event Hubs to process the credit card transactions. And also, Event Hubs will be used to find the anomaly detections and application loggings. So to streamline the application loggings and to give that data to the monitoring devices to identify the any abnormalities in the application functionality or any services is not available, we can able to monitor, and user and device telemetry streaming and live dashboards. So as we said that you can able to connect with Power BI directly, integrate with Event Hub, and you can able to stream the data, and you can visualize the data which you get from the Event Hub and to analyze the data. So these are all the Event Hub use cases. Now we talk about Event Hub key features. So in order to create an Event Hub, first you need to initiate the Event Hub namespace. What is the Event Hub's namespace? Event Hub namespace is a container, management container, which helps to hold the, or you can able to create the multiple Event Hubs under the same namespace. So Event Hub namespace provides the integrated network endpoints, range of access control, network integration management features. For example, you have created 2 Event Hubs and you want to give a access to these 2 Event Hubs with using one access key. So where you have to create that access key is namespace level. If you want to give the access to all the Event Hubs using the one key, then you have to use the namespace access key, because it is a container. So it will, whatever the access keys you are accessing from the namespace, it have access for the both Event Hub. For example, if you want to give access only for this particular Event Hub, then you can use this particular access key, SAS access keys. Now let's talk about Event Hub pricing tiers. So there is 3 tiers is available under the Event Hub, and different features is offering based on your requirement. You can able to choose that. So maximum size of Event Hub publications is, if you choose the basic tier, it is 256 KB, standard is 1 MB, premium is 1 MB. So the maximum size of that byte stream is 256 KB in basic, standard is 1 MB, premium is 1 MB. If that size is maximum is reached, then that particular message will be rejected. Number of event consumer groups for Event Hub is 1 consumer group is for basic, 20 for standard, 100 for premium. Maximum retention period. So the data retention period for the event data is 1 day for basic, 7 days for standard, 90 days for premium. Number of partitions for Event Hub is 32 for basic, 32 for standard, 100 per Event Hub. Number of spaces for subscription is, namespaces for subscription is 1000 for all 3 tiers. Throughput. Throughput is nothing but a pre-purchase events. So you are taking the capacity of data you can transfer per second. For example, if you choose the basic tier, you will get if you choose 1 unit, then you will get the 1 MB per second, or the size of 1000 events equals to 1 MB. So even if you are transferring the 1000 events per second also, the size should not cross 1 MB. And when you are sending out the request, it will offer 2 MB per second or 4096 events per second. So the egress also should not cross, the total size of 496 events should not cross 2 MB, and it is same limitation for standard as well. And in premium there is no limit. And you can capture the data, whatever the data you are collecting through Event Hubs, you can capture and store into the any Cosmos DB, or you can store into the blob DB, blob storage, or you can use any other DBs. So it is not providing in basics, so the capture option is not available in the basics, and it is available in standard, but you need to pay per hour, and in premium it is included. So this is about the pricing tier. Now we talk about the one more key feature of Event Hub is publisher. Who is publishing, who is generating the data, and who is dropping the data at the Event Hub. So the entity that sends the data to Event Hub is an event publisher. So who is generating the data and who is publishing the data calls event publisher or event producer. Event publisher use the Azure Active Directory based authorization using the JW tokens, or they can use the shared access signature, that is SAS token, to gain the publishing access. Event Hub publishers can publish the events using HTTPS or AMQP 1.0. So what is this AMQP? It is a protocol to transfer the data from the publisher to the Event Hub. So Advanced Message Queuing Protocol, AMQP is Advanced Message Queuing Protocol. So AMQP is a framing and transfer protocol. We already know it is helping to transfer the data. So what is framing? The framing means that it provides a structure for the binary data streams that flow in either direction of the network connection. So it will give you a structure for the binary data streams. So whatever the devices are generating here in the producer section, it will transfer as a binary streams. So it will provide a structure. So it will limit the size of that structure. For example, if you set the limit is 1 MB for event binary data streams, it will help to transfer that. And AMQP requires the establishment of persistent bidirectional socket in addition to the transport level. AMQP is little cost than network cost when initializing that session. So comparing HTTPS, it is higher in network costs. AMQP has higher performance for frequent publishers and can achieve much lower latencies when used the anonymous publishing code. So using this protocol, we can achieve the frequent high performance and low latency for the frequent publishers. So this is about the publisher. So here we have to understand is Event Hub who receives the data from the producers or publishers and can transfer the data to the consumers. So how this publisher can transfer the data to the Event Hub is through AMQP protocol, or you can use HTTPS. So this is about publishers. Then we talk about the partitions. When we transfer the data from the publisher to the Event Hub, we cannot put whole data. For example, it is generating 1 GB data, or maybe more than that this particular device is generating. So we cannot transfer the 1 GB data at same time. Or might be this, here we have installed the multiple devices like a smoke sensors or any security sensors like a locks security sensors, or some devices are installed. So you want to transfer the data in parallel. So you cannot wait until the smoke sensors is sends the data, until these lock sensors cannot wait. It has to transfer the data in parallel. So the event hub organizes the sequence of events sent to the event hub into one or more partitions. The new events arrive added to the end of the sequence. So these partitions data, whatever the data we are adding to these partitions, it is a committed log. So that log information will send to the receivers. So what we are saying here is the partition can be a thought of committed log. Partitions holds the events data that contains the body of events, user defined property back describing the event, metadata such as its offsets in the partitions and its number of streaming sequence and server side timestamp which it was accepted. Perfect. I will tell in more detail that. For example, as we talked in earlier, that these are all the gated community houses. In these particular houses, we have installed the multiple devices, like one is smoke sensors and one is lock sensors. If there is any abnormalities in the opening of lock or something, that particular data also should transfer to the event hub to send to the receivers who monitoring those logs. Perfect. But when we install the multiple logs or when we install the multiple devices, that particular device data has to transfer in parallel. It should not wait in a to transfer the data from one device data first and next. It could not wait. It has to transfer in parallel. And also, what we have to achieve is we have to transfer whatever the data we are transferring through Event Hub. It should be added at the end of this partition. So meaning that which is comes first, it will process first if you use the partition ID. So meaning that if you create a number of partitions, this particular devices is transferring the data without specifying the partition ID. Meaning that they are not specifying any partitions ID. For example, this is partition 1, partition 2. In this particular binary data, if you send partition 1 or if you tag the partition 1 for that particular message, then it will process, it will drop at the partition 1 only. For example, if you did not specify any partition, then this particular data will be drop at any partition based on the load. Whatever the load is there, it can be drop at any partitions. But in this approach, without specifying the partition, the data which we are dropping into the partitions, we cannot committedly tell that which message can deliver first. It can deliver anyway, anything, because for example, this particular data which is we are dropping here using the partition ID, so we can tell that this particular message is dropping at partition 1 and these are all will process first in and first out. So meaning that it will process at first, then this one, then this one. If you don't specify this, just drop those binary data, then we cannot ensure that they are processing in order. So in total, these partitions will help to process the data in parallel. So next we talk about the consumers. So until now what we discuss is these are all the event publishers or the producers who generates the event. Once they generate the events, they will connect to the event hub and they will drop the data, binary data at the partitions. Perfect. Once they drop the data at the binary partitions, this particular event hub will help to transfers the data to these consumers. These are all the boxes which we created here. So they have subscribed these particular topics. So they will consume the data, this event hub, whatever the data available in these partitions, it will transfer to these consumers. So the consumers who receivings or who reads the event data from the event hub is called the consumers. Now consumer groups. So the consumer group is a logical group, meaning that this particular 4 boxes belongs to the consumer group 1. This particular box, whatever it is, belongs to consumer group 2. So these all consumers is been tagged to a logical group called the consumer group 1 and consumer group 2. So a consumer group is a logical group of consumers that reads the data from the event hub or Kafka topic. So what is the advantage of creating these consumer groups? The consumer groups enables the multiple consuming applications to read the same streaming data in the event hub independently at their own space with their offsets. What is these offsets? So we talk about in partitions we can maintain these offsets. So offset is nothing but a cursor. For example, this consumer in these partitions there is a 1000 1000 bytes of data is partitions has been transferred. Then this consumer group has read until 200 and it stopped read. So when it is up again, it is starting reading the events from these partitions. It has to read from the 201 event. It should not go again to read from the event 1 to 1000. So that's the reason the offsets will help to remember what is the last event has been read and where they have to read, or they can set a specific events they can set to read from there. Allows you to parallelize the consumption of messages and distribute the workload among the multiple consumers. So one more advantage in the consumer group is it will parallelize the consumption of the messages. So there is a multiple consumers we have created. So ethically, like the logically recommended way is one partition, one consumer group should be sufficient, meaning that it won't process the duplicate. If you create multiple consumers for one partition, meaning that there is a chances of processing the duplicate data. So you need to handle at your application should not process the duplicate data. If there is any duplicate data, you should not process at your end. So ideally the recommended is you should have an event, one event or one consumer for one partition. So there won't be any duplicates. So these are all the consumer groups.